Good morning. We will continue the second unit. I am Dr.M.EZHILAN speaking, Department of Mechanical Engineering, Rohini College of Engineering and Technology. What is meant by entropy? It is a thermodynamic function of the state of the system. Can be interpreted as a amount of order or disorder of a system. As with internal energy, is a change in entropy is important and not in absolute value. Change in entropy. The change in entropy, the notation is called as delta S of a system. An amount of thermal energy Q is added to a system by a reversible process at constant absolute temperature. T is given. Delta S equal to total amount of heat divided by given temperature. Now you are going to solve a problem. Here the problem is a heat engine removes 100 joule is cycled from a heat reservoir at 400 Kelvin and exhausts 85 joule of thermal energy to a reservoir at 300 Kelvin. Compute the change in entropy for each reservoir. Here the given data, the heat engine removes Q equal to minus 100 joule and temperature of the heat engine reservoir 400 degrees Celsius Kelvin and exhaust Q equal to 85 joule and reservoir temperature at 300 Kelvin. Since the hot reservoir loses heat, we have that delta S equal to Q by T equal to minus 100 divided by 400 Kelvin. The answer is minus 0.25 joule Kelvin. For the cold reservoir, we have delta S equal to Q by T 85 divided by 300 equal to 0.283 joule Kelvin. Therefore, the increase in entropy of the cold reservoir is greater than the decrease of the hot reservoir. Entropy for ideal gas. An expression for the entropy change of an ideal gas can be obtained from equation ds equal to du by T plus pdv divided by T, or ds equal to dh by T minus v dp divided by T, by employing the property relation for ideal gas by substituting du equal to cv dt and p equal to RT divided by V into equation 1. The differential entropy change of ideal gas becomes ds equal to cv dt by G plus R dv by V. V is nothing but it's a specific value. The entropy change of the process is obtained by integrating this relation between the end state delta S equal to integration of Cv dt by T plus R ln of V2 divided by V1, that is equation 3. A second relation for the entropy changes of an ideal gas is obtained in a similar manner by substituting dH equal to Cp dt and V equal to RT divided by P into equation 2 and integrating. The result is delta S equal to integration of Cp dt by T plus R ln of P1 by P2, equation 4. From equation 3 and 4, we see that the constant volume process. So delta S equal to integration of Cv dt by T So CV ln of T2 divided by T1. For constant pressure process, we have delta S equal to integration of Cp dt by T. So Cp ln of T2 divided by T1. For isothermal process, delta S equal to R ln of V2 divided by V1 equal to R ln of P1 divided by P2. Next, we are going to discuss about the Carnot principle. The Carnot cycle is a thermodynamics process that describes how a fluid is used to convert thermal energy into work. The important characteristics of the Carnot principle: high efficiency, multi-source engine, better reliability and easier maintenance, reversible, safe, discrete and oxygen free, modularity and flexibility. PV diagram. The pressure volume diagram for use describes corresponding changes in volume and pressure in a system. PV diagram, called as indicator diagram, was developed by James Watt and his employee John Southern to improve the efficiency of the engines. This is a PV diagram. Isothermal segment AB and CD occur when there is perfect thermal contact between the working fluid and one of the reservoir, so that where heat is needed to maintain constant temperature will follow into or out of the working fluid from or to the reservoir. Then now we have to consider the volume and pressure. First, A to B is a isothermal, B to C is a adiabatic, C to D is a isothermal, and again D to A is a adiabatic. Thermal efficiency of an engine working between the temperature of T1 and T2, that is increase the temperature difference under which the engine works. Efficiency equal to 1 minus Q2 divided by Q1.